Hello everyone, welcome back to the course on measurement and instrumentation, and today is the first lecture of our 11th week. Today we are also going to start a new module which is known as data acquisition system, and this is our fifth module. This is fifth module as well as this is the last module in this course on measurement and instrumentation. This module is very important and we are going to discuss this over the next 10 lectures in week 11 and week 12. We will be using various topics that we have covered over the last 4 modules in this data acquisition system, and we will see that how the knowledge that we have gathered in our previous module are helping us in designing a good data acquisition system. Okay? So, let us start understanding this system in little detail. Okay, we have seen that real world parameters are mostly analog. We acquire it by different sensors and transducers. Like if we acquire it using say a temperature sensor, we usually see, say for example, if I want to measure temperature of the ambient, it is typically a kind of analog in nature and it is changing every time continuously over say an hour or a day. Okay. Similarly, if I am trying to measure certain pressure, that is also a kind of analog signal. Similarly, you measure flow, displacement or speed. Most of the real world parameters are analog signals. Okay. Now, the processors that we have can process the digital data, and therefore, we need systems which can actually measure or which can provide the digital data, which can convert these analog signals to digital signal to feed up these processors. Of course, you have different stages of conversion of these analog signals to digital signal and so on. Okay. You also want to store them in digital form and then analyze the data, or sometimes you simply want to display them. Okay. All of these that we are talking about constitute a system that is known as a data acquisition system. Okay. So, if I have to define a data acquisition system, I can say that it is a system that measures physical variables, convert them into electrical signal and process them digitally. We call it a data acquisition system or a DAS. Sometimes it is also known as DAC. Okay. Data acquisition system. Okay. Sometimes this data acquisition is more than enough. So, sometimes we call it DAS or sometimes we call it DAC. Okay. Both are the same terms. Okay. So, if you see, this system is able to measure some physical variable, all right. It is also able to convert them into electrical signal and it is also able to process them digitally. Okay. Now, this word is data acquisition system has emphasis on acquisition or data acquisition. Okay. But this sometime it can be misleading. The idea is not only to acquire the data, but the idea is to convert them into electrical signal as well as to process them. Okay. So, just by acquiring the data is not sometimes sufficient. Acquiring the data is kind of done when you have acquired it maybe in the analog signal. Okay. In the analog format. But data acquisition system will, what it will do is it will not only measure, but it converts and then process them digitally. Okay. The DAS converts the real world physical signal, which is the analog signal, into digital data that a processor can understand and analyze. Okay. Now, physical parameters that we have seen can be a temperature, a pressure, a displacement or simply a strain. Okay. Then like if I take an example of say strain, say I have wire and because of say some tensile force it get say elongated, or there is another force because of which this get shorted. Okay. Now, all these changes is happening in terms of length, say L plus delta L or L minus delta L, say initial length was L. However, data acquisition system okay, will give outputs in terms of voltage or currents, because these are the electrical parameters which can be further processed. Okay. Therefore, the first stage of any DAC should be a transducer or a sensor, all right, or a sensor. Okay. Now, in general, if I talk like a technician is logging the temperature of a certain system, like it can be say simple oven on a piece of paper, okay, he is also acquiring the data. This is also known as data acquisition. Okay. However, in a more complex example, data acquisition can involve the monitoring and collecting of data from a large scale industrial process with multiple interconnected sensors and variables. Say for example, say it is a plastic industry, okay. Say it is a industry where you have say recyclable plastic, and say with this recyclable plastic you are trying to make a chair. Okay. Now, this process will involve multiple stages, like you have to recycle it, you have to heat it, then melt it. So, heating, because of which it get melted, then solidifying it say in some form, okay, and in the process there are say n number of gases also getting emitted. All right. So, number of things are happening over here. Okay. So, you require sensors to monitor these gases. You need temperature sensor. You need temperature sensors to monitor the heating of this. Say for example, you are trying to melt it, okay. You may require viscosity monitors. To monitor the melted plastic, and similarly you need multiple sensors in this. So, it is a very complex problem, okay, and you can monitor all these parameters using a DAX system. Okay. So, number of variables are available and number of parameters are getting monitored simultaneously, and this is kind of monitoring and collecting of the data from this system, and this is also a kind of data acquisition system that is required for any industrial process. Okay. So, the DAX system must acquire the required data accurately at an appropriate speed at the correct time. Okay. So, for example, if I consider this, okay, the example that we were understanding, okay. Now, the melting has been done, okay. Now, I have to solidify it in the form of a chair, for example. Okay. So, my data acquisition system should acquire the data accurately at an appropriate speed and at the correct time. Like if say for example, if the melting is done, it should tell us in the real time that the complete melt has happened or say half of the melt has done. Okay. So, if I do not have that idea, I may not be able to proceed further for solidifying it. Okay. It should efficiently utilize all collected data to provide meaningful information about the system's current state to the operator. Okay. The system must continuously monitor the entire plant to ensure safe, reliable and optimal real-time operations. Okay. So, the objective of a data acquisition system, you can say that it should provide an effective human-machine interface. It should enable a clear communication, say from one processor to one processor or maybe one system to one system. Okay. Quick identification of problems or problematic areas. Okay. Another objective should be to minimize the downtime of the system, okay, and maximize the throughput, okay, and all of this should be done at a minimal cost. Okay. The system must be capable of collecting, summarizing and storing the data for further analysis, diagnostics and record keeping purposes. Okay. It should compute performance indices of the system using real-time online data. The system must be flexible and scalable to accommodate future expansions and modifications. Okay. A good DAC will exhibit high reliability, particularly in the harsh ambients. Okay. So, if I summarize this DAC system or DAS system, it will look something like this. Okay. It will have a sensor or transducer at the first stage, where it will collect the physical parameters or where it will first interact with the real world. Okay. Once the data is collected over here, okay, the signal conditioning unit will be fed with the data, okay, for further conditioning of the signal. Okay. We have a multiplexer after that. Okay. We have a sample and hold circuit, a ADC, and further it is fed to a processor and then to a storage unit or say to a display. A typical DAS system looks something like this. Okay. Some of the component may be missing in some say low frequency systems, but this is in general a very common composition of a DAS system. Okay. Now, if you see, as I was mentioning earlier, that this is the first stage. We have discussed these sensors and transducers that is used over here in this system in more detail. Okay. Now, this will convert any physical quantity into some electrical signal, and output can be depending on what kind of transducer it is. Output can be voltage, resistance, or variation of if capacitances or inductance, depending on what system I am using. Say, let us consider only in terms of voltage or current, because everything can be converted into these form of electrical values. Okay. So, let us consider that the sensor's output is in terms of voltage or current. Okay. Like for example, if I have a temperature sensor, say I am using a thermocouple, output will be in certain millivolt or microvolt, and that is why I mentioned that let us consider that output is in terms of some voltage or current value. Alright. Now, the output from the sensors are fed into the signal conditioning circuit, which is the next stage. Okay. Signal conditioning equipments include any equipment that assists in transforming the output of a transducer to the desired magnitude or desired form. Okay. Now, this form is required by the next stage of the data acquisition system. Okay. So, usually this is a major work of a signal conditioning unit, but we have also seen in our discussion on signal conditioning circuits that usually the raw signals are very weak and sometimes it is noisy also. Okay. So, these signal conditioning units will take care of these weak signals by doing certain amplification or some other process. Okay. And similarly, noise can be reduced or minimized by certain signal processing. Okay. Non-linearity is another factor that is available from the output. Okay. And this signal conditioning unit will take care of any non-linearity in the output of this transducer. Okay. So, if I summarize, a signal conditioning circuit or signal conditioning unit will perform various jobs like amplification, filtering, it also do isolation, linearization, and it also helps in excitation supply. Okay. Like we have already seen amplification in detail, where we have discussed op amps and instrumentation amplifier. So, idea is to increase the signal strength that is coming from the sensor or transducer, and this improving in the signal strength will also simultaneously improve the signal to noise ratio, and ultimately we have seen that for any measurement we want signal to noise ratio usually greater than 3. Okay. And for quantization, so this is for measurement, and for quantization we have seen that signal to noise ratio should be greater than 10. Alright. So, this can be done over here. Okay. It will improve the signal strength, and by which the signal to noise ratio can also be improved. Okay. So, as I was mentioning that we have seen various amplification methodologies and amplifiers in our previous discussions, like operational amplifiers and how they can be used to construct instrumentation amplifier and so on. Okay. Similarly, we have also seen other scheme of filtering, okay, which is used to remove the unwanted frequencies. Okay. We have seen different active and passive filters, including low pass, high pass, band and notch filters, or say band reject filters. Okay. These are done to improve the signal to noise ratio further, or by eliminating the noise component, or at least unwanted signal as well. Okay. Similarly, the data acquisition system can also provide with isolation. The purpose of isolation is to protect the system, avoid ground loops and improve the safety. Okay. We have seen grounding and shielding in detail in our previous lecture. Okay. I mean, apart from that, there are other methods of isolation, like we have optical isolation for optical instruments, we have transformer isolation and so on. Okay. For nonlinear sensors output, we have various issues, like there can be measurement errors, complex calibration is required for nonlinear outputs. Okay. Then signal interpretation, particularly the interpolations and all, is difficult. Okay. And accuracy in digital processing is also reduced. Okay. So, you want to linearize your system or linearize the output from the signal, and linearization is the process of converting a nonlinear sensor output into linear relationship between input and output. It can be a, say, linear piecewise approximation or by other means. Okay. But usually the output from this signal processing unit, okay, so you fed a nonlinear signal to it. Okay. There are various linearization circuits which can give you output in a linear form, maybe as I have mentioned in the piecewise approximation or by correcting some slope or something. Okay. Then excitation supply is another important constituent of a signal processing unit. Okay. It is a controlled voltage or current source provided to active sensors to enable them to produce an output signal. We have seen that biasing is required for any kind of active sensors, and this excitation supply means exactly the same. Okay. Some sensor we have seen that do not generate signals by themselves, like piezoelectric sensors, but they require external power, say for example a resistive sensor for example. Okay. There you have to provide a proper biasing, or say 2 volt, 3 volt or so on, okay, to collect the data. Okay. So, this sensor's requirement is excitation supply. Maybe even if you are talking about a Wheatstone bridge configuration or a potentiometric sensor, everywhere you will require this excitation supply, and this particular unit take care of that. Okay. So, next important part of a data acquisition system is a multiplexer system, or sometime also known as MUX system. Okay. So, multiplexing is the process of sharing a single channel with more than one input. Okay. So, for one input it is okay that you give the input and then you have an output, but when you have multiple channels, when you have only one channel and you have multiple inputs, okay, then you have to basically share the channel itself in place of having multiple channels. Okay. And this job is done by the multiplexer. Okay. So, a multiplexer basically accepts multiple analog input and connects them sequentially to one measuring output. Okay. So, multiplexing is a means of using the same transmission channel for transmitting more than one signal. Okay. It becomes necessary in measurement systems when the distance between the transmitting and receiving point is large and several quantities are to be transmitted simultaneously. Okay. So, if a separate channel is used for each quantity, the cost of installation, maintenance and periodic replacement become very large, and therefore, a single channel is used which is shared by various quantities that has to be propagated, or that information has to be propagated over the same channel. Okay. So, multiplexing is commonly accomplished by either time or frequency sharing of the transmission channel between the individual quantities. We will see the multiplexing methodologies in the next lecture in more detail. Particularly, we will focus on time and frequency sharing of the transmission channel. Okay. But today let's have a basic overview or understanding about a data acquisition system. I hope that it is clear that multiplexer is a very crucial part of this DAS system when you are using multiple sensors in the input. Okay. When you have multiple sensors and they are connected, this multiplexer will select only one signal at a time, and therefore it will reduce the hardware cost. Like you can have say 8 channel multiplexer, and all these inputs, like the multiplexer is giving say only one output, so you have say 8 inputs, and then you will require only one ADC to process this data. Okay. So the good example can be a 8 channel multiplexer and a ADC system. Okay. Then you require a sample and hold circuit in a data acquisition system. Okay. We have seen in detail what is a sample and hold circuit. The same circuit is utilized in the DAS system. Okay. So this sample and hold circuit samples the analog signal at specific instant, holds the value constant during the ADC conversion, because ADC will require stable input, because we have seen that the output is changing continuously. Okay. But to convert this analog to digital signal, it will require a fraction of time, okay, where the analog input is constant. If it is changing, the output will definitely be erroneous in nature. Okay. So this sample and hold circuit is desired in a DAS circuit, particularly for the high frequency signals. Okay. Then we have ADC, and ADCs are very important part of DAS system, particularly for the single channel DAS system. It becomes even more important component. Okay. So ADC we have discussed in detail in our previous lectures. The idea is to convert the analog voltage into digital binary number. We have seen that the process is a little complex, and there are 3 stages in this conversion. Okay. We have also seen in detail regarding various parameters that is important for the ADC, like we have seen that what are the resolutions of ADC, what is the sampling rate and accuracy. All these things are desired for a good DAS system. Okay. Analog to digital converters used for the DAS application are usually designed to receive external commands to convert it into digital signal, mostly analog commands. Okay. For DC and low frequency signals, a dual slope type converters is used. We have discussed about the dual slope type analog to digital converter in detail. Okay. The advantage of using this dual slope type ADC is that it has a linear averaging capability. Okay, and also has null response for frequency harmonically related to the integrating period. Okay. Now AD converters based on the dual slope techniques are used for the conversion of low frequency signals from, when I say low frequency signals, there are a number of transducers which has low frequency outputs like thermocouples. Okay. And it becomes more important when you are taking the data in presence of certain noise signals. Okay. Then the higher speeds are obtained by preceding the AD converter by a sample to hold signals or sample to hold circuits. Okay. The sample to hold circuit is particularly required with successive approximation type AD converter, which is very popular for higher speed signals for the conversion of analog to digital signals. Okay. Because at higher rate the input is changing, and it is also generating lot of non-linearity errors, and for the conversion process to take place within the time period, okay, sometime it is crucial to hold the signal for ADCs. We have seen that in all kind of ADCs this sample to hold circuit is required, but its importance is even higher when you talk about high frequency input signal. Okay. Then the important constituents of this data acquisition system is a processor which controls the sampling, which can store the data, or at least which can command to store the data. Okay. Then it can also do performance analysis, it can display the graphs and apply digital filtering of the data that has been processed already. Okay. Then storage and display unit's job is to store the data. Okay. It can be on the system or it can be on cloud. Okay. It has monitors to display the data, it can plot the data. okay, means that you have a real time dashboard where you can actually visualize the data that is being acquired or which has already been processed. Okay. Now, there are various performance characteristics of DAS very similar to what we have seen for the sensors. Okay. Like we have discussed the static and dynamic characteristics of sensor system. Similarly, for DAS you have different performance characteristics including resolution, accuracy, dynamic range, linearity, drift and so on, but along with that we also have very specific to DAS like sampling rate. Okay. Even noise become very crucial for a DAS system. So, these are some of the parameters on which our DAS system is evaluated. Okay. Now, there are various ways of classifying the data acquisition system. The very basic classification can be based on the environment in which these DAS systems are operated. Okay. Now, based on the environment, you have two DAS systems. Okay. One is those suitable for favorable environment like where you require minimum RF interference and electromagnetic inductions. Okay. And then those intended for hostile environments where this interference and all are maximum. Okay. So, when you intend or when you are constructing this DAS system for these two environments, the fabrication or you say the assembly of this DAS systems completely vary. Okay. Like those suitable for favorable environments can be some systems which will be used in say laboratory instrumentation or laboratory instrument application. Okay. Or say in the high calibration test instruments. Okay. In these, the systems are designed to perform tasks oriented more towards making sensitive measurements than there is no provision for protecting or integrating of the analog data. Okay. So, you are not focusing on these parameters, but what we are focusing more on making the DAS system more sensitive. Okay. However, for the hostile environment, the challenges are different. Okay. So, you are measuring the data in presence of the external say electrostatic field or electromagnetic induction or other challenges. Okay. In that, the idea is to measure and protect the integrity of the analog data under these conditions. Okay. Such measurement conditions arise in say aircraft control system, in the electrical power systems and in the harsh industrial process control systems. In all these cases where the temperature is very high or the system is moving very fast or when you are dealing with very high voltage systems, these are the hostile environments where for designing the DAS system you have different challenges. Okay. Most of these hostile measurement conditions require device capable of a wide range of temperature operations, excellent shielding and reductant path for critical measurements. Okay. Then based on the number of channels, you have two type of DAS system. You have single channel DAS and you have multi-channel DAS. Okay. A single channel data acquisition system is used to capture data from one sensor at one time. Okay. So, the system is very simple, it is cost effective, easy to use and suitable for any basic laboratory measurements. Okay. However, a multi-channel DAS are little complex systems and they are designed to capture data from multiple sensors simultaneously. Okay. These systems are suitable for more complex application where various type of data must be collected and analyzed in real time. Okay. So, multi-channel DAS can do simultaneous data capture. So, multi-channel systems allow the collection of multiple signals. For instance, you can measure multiple physical parameters like temperature, pressure, humidity at the same time. Okay. Now, these multi-channel DAS are made in such a way that they have high throughputs. Okay. So, they can handle large volume of data at one time. Okay. Now, they also have capability of flexible data integration, means that cross analysis of signals and comprehensive system monitoring is possible with the multi-channel DAS. Okay. Then there is another classification of data acquisition system, that is analog data acquisition system and digital data acquisition system. Okay. So, we will see this analog data acquisition system and digital data acquisition system in more detail in our next class, but in brief Analog data acquisition system, all signals remain analog and they use chart recorders and display. They have limited flexibility. You may have to face this cross analysis and other things. We'll see them in detail. Okay. However, the digital data acquisition system, which are actually the most common data acquisition systems, are have better accuracy than the analog data acquisition systems. Okay. We'll see both of the system in little detail in our coming lectures. Thank you.